may have written the definition or the introduction is just slightly different, but it's the same rules in the book. We're studying inner products and cross products today of vectors. And so the rule for an inner product is if vector A and B are two vectors with coordinates A1, A2 and B1, B2, the inner product of vector A and vector B is defined as vector A dot vector B, where it's A1, B1 plus A2, B2. Okay? Two vectors are perpendicular if and only if their dot product is equal to 0. Did you get all that? Hey, look at that. This just drives me nuts. So A dot B is equal to 0, then it's then they're perpendicular. Okay? Two vectors are inner product is equal to 0, then the two vectors are perpendicular. So then for space, two vectors in space, all we do is add that third dimension out there. Okay? Cross products of vectors is in space only, and I just didn't have room next to it to write this out. Come on. So vector A cross vector B, these symbols mean determinants. Whoops. These symbols right here mean find the determinants of these vectors. I'm sorry, of these matrices. Okay, they mean to find the determinants of the matrices. And I'll remind you how to do that in just a minute. That's from algebra 2. If you didn't get skipped, which I'm thinking it might have with you guys. And move it, what? They're in the way, huh? I added a little definition here to make sure you understood where these letters come from. Vector A is A1, A2, A3. Vector B is B1, B2, B3. If we wrote those two vectors as a matrix, we would put whichever one is first in this cross product has to go on top. So whichever one's first has to go the first row, the top row. Okay? AJ made a good point. That X there means it's a cross product, not a dot product. The directions on what you're accomplishing are totally different between those two. Okay, just want to make sure that you understand on the unit vector I, notice this column was taken out of that. And so we go A2, A3, B2, B3. Okay? And on the unit vector J, then this column is removed, leaving us with A1, A3, B1, B3. And then on this one over here, the J unit vector, the K unit vector, then the third one is removed. So we get A1, A2, B1, B2. Okay? That's how we get these. That's where they come from. Alright, let's move down a little bit. I think we have one to practice here. Just a simple find the determinant, find the cross product of these two. Actually, let me clean this up. Let's find the determinant of this, okay? Well, what did I do? I don't know what I did. That's what I meant to do. Okay. And so, to find the determinant, we use this symbol. And the reminder is, that's why I had find the cross product there. Okay? It means a little different than the cross product that we're studying. That's why I erased it. And before you had a matrix that said find the cross product, it just meant find the determinant 3 times 4 minus 2 times negative 1. And 3 times 4 is 12, minus a negative 2 gives me 14. So in algebra 2, we would have said find the cross product, the answer would have been 14. Okay, today we're saying let's find the determinant of that, the answer is 14. That's what we have to do on each of these to find out what this number represents, and what this number represents, and what this number represents. Okay? We have to find that. Now, I also want to point out, notice that sign. So what? Subtraction. And this one is addition. That's part of the definition of how to find the cross product. It's the I term minus the J term plus the K term. Okay? So we didn't just randomly put put symbols there. That's what the rule requires. Okay? So let's find it's a dot here. So let's find the inner product of these two. Should be simple. I'll pause, let you do that. Then we'll do it together. We just all agreed that these two vectors are perpendicular because their inner product is 0. And please tell me how I find that. To me at once. Let's do this. Taylor, you tell me. Okay, go. Give me the real numbers now. Okay, and so this gives me negative 32 plus 16 plus 16, and I agree those two are 32. Negative 32 plus 32 is 0. So the inner product is 0, meaning these vectors are perpendicular. Okay? Now, if I tried to draw a plane, can we imagine that's a plane? And we have a vector like this, and a vector like that. We're saying that these two vectors are perpendicular. Okay? When we find the cross product of these two vectors, we will find this vector. Okay? The cross product represents a vector that is perpendicular to both of the other vectors. Okay? The cross product represents a vector that is perpendicular to both of the two vectors you're using to find the cross product. Okay? So in this example, don't look. Ah, there, you didn't see anything. We need to find a cross product of this. And when I set this up, I truly would set it up this way, and I wouldn't get into these numbers until I did all this, because I'm going to tell you, I'm here to tell you, many of you are going to make mistakes on at least one of those. Okay? So be cautious. Don't get in a hurry to get to your numbers. Okay? The numbers you will remember. It's the simple things like the signs and the setup that you're going to make a mistake on. So set that part of it up first. Okay? Now if we write this as a vector, as a matrix, 1, negative 3, 2, and then 5, 1, negative 2. That would be my matrix. Okay? The row that goes on top has to be the first vector. So how do we find what goes in here? We eliminate column 1, and we write the rest of that matrix down. So it's negative 3, 2, 1, negative 2. And then to go to the next one, what do we eliminate? Column 2. We eliminate this column. So we get 1, 2, 5, negative 2. Then we go to the next one, Trenton. We eliminate this column. What's that one going to say? What's this one over here going to say now if I eliminate this column? What? Trent, yeah.
0.
If I eliminate this column, what do I write here?
1, 5, 3, 1.
Okay, can you read the first row for me?
1.
Okay, and then what?
-3.
There you go. Okay. You said 1, 5, negative 3, 1. I wasn't sure how you were reading that, how you meant to write it. You probably meant it right. I just didn't understand it right because I was expecting to read across first. Okay? So that's what we get. Now, let me erase this so I have room to work here. Now we want to simplify. What number represents this? How do I find it? Alexis? Okay, so I get... Okay, I'm going to go ahead and write it out. Minus 1 times 2, right? And that's I. Minus, Jarrett, what goes in this one?
1 times 2. And 5 times 2.
No. This came from this.
1 times -2.
Okay?
And then 5 times 2.
Okay, agree with that? Plus, Kara, what goes in this one? Okay. Nobody's saying minus, but that's what has to happen there. So if we simplify that, 6 minus 2 is 4i, minus -2 minus 10, which is -12. Minus a -12 is plus 12j, plus, it's going to end up being a negative. 1 minus, oh no it's not, it's still plus. 1 minus a -15 is plus 15, so that's 16k. So that represents that vector. Remember we said the cross product gives us a vector that's perpendicular to each of those original 2 vectors. Okay? And so this represents our vector that might look something like this. Okay? So if I took the coordinates of these 2 vectors and found the cross product of them, they give me, that result gives me this vector that's perpendicular to each of those 2. Okay? It'll be perpendicular to each of those 2. scary. That almost looks like it's a real picture there, doesn't it?
Terrifying.
What a great drawing. All right. Any questions on how we found this? This is the that's our that's our vector, which is our cross product. Yeah. They might ask it in this form. What would this be? 4, 12, 16. That's correct. Okay? And they might want you to show, they might give you a vector and they might say, show that this is a cross product of these other two vectors. Does that sound scary? Okay? So we're working backwards? Kinda. We're working backwards in concept. What did I tell you this represents? A perpendicular vector. How do we know if two vectors are perpendicular? Their dot product equals 0. So if we took this vector and this vector and found the inner product and it was 0, then that means it's perpendicular. If we took this vector and this vector and found the inner product and it was 0, that would mean they were perpendicular.
Well, they have.
If they're both perpendicular, then that means this is the cross product of those two. You have a question? Yeah. Still thinking it out?
Yeah, I understand that.
Okay. That's it. The assignment today. Here it is. Today we're doing 11 through 25. Tomorrow we're going to add 27 to 37. That's only 6 questions, so you'll have time to finish other things also. Now some of these are a little more application. Some of these last 6, they're going to require a little more thought. Yeah, sorry. That's horrible. We make this stuff applicable.
For like.
They need to record this question?